Puzzles 2017.
So today I'm going to talk about Chakra, which is the Microsoft Edge scripting engine. There's actually a bit of a backstory to this talk that involves recon, because at the last recon I gave a talk on how to find vulnerabilities in Adobe Flash, but I was sort of finishing up my work and trying to figure out what to do next. And someone suggested to me that I look at Chakra. And at that point, I didn't even know that Microsoft had open sourced their JavaScript engine. But I gave it a shot, and I ended up having a lot of bugs. So today I'm going to talk a bit about what I found and the approach I took to find them. So who am I? I'm Natalie Silvanovich, and I'm a security researcher on Google's Project Zero. I'm an ECMAScript enthusiast. I love finding bugs in browsers and Flash and pretty much anything that processes scripts. So what is Edge and what is Chakra? Edge is the new Internet Explorer. It's Microsoft's new default browser on Windows 10. And Chakra is Edge's open source ECMAScript engine. It's regularly updated, so it's kind of nice. They didn't just upload the code once and then that was it. You can actually see active development and see the CVEs as they get fixed and that sort of thing. And it accepts external contributions, so you can be the change you want to see in Microsoft Edge. So what is ECMAScript? ECMAScript is the JavaScript standard. It's what developers implement when they try to create an ECMAScript engine. And it is a living standard. There's always new versions coming out. The most recent one was ECMAScript 7, which was released in June. So why does newness matter? Something you realize quite quickly when you look at JavaScript engines is that the standard does not specify implementation. They say what the script needs to do, but not how to implement it so much. So when you're creating a new ECMAScript engine, developers need to make design decisions, and the design decisions are somewhat untested. And sometimes there's trade-offs. There's things like security versus performance, how many checks do you put in. But sometimes there's like other reasons things get done, ease of development, that sort of thing. And quite often, if you look at some of the older browsers, you can see where this stuff went wrong. You can see, things that got rewritten, things that they made a concerted effort to get rid of bugs in. Some parts, especially WebKit and Firefox, you can see like all the angry comments by developers as they tried to fix a certain part over and over. But you don't have this advantage with a new ECMAScript engine. And this is both from the side of trying to secure it. It's not clear where the weak points are, and also from trying to find bugs. There wasn't as much to start with because there hadn't been so many bugs found yet. And in general, attacks mature over time. I think this is really kind of the first few people who've looked at Chakra, and I'm sure there'll be many bugs in the future. One thing I was a bit surprised about is I thought that there would be not a lot of bug collisions because, in a new product there should be a lot of bugs and they haven't all been found yet. But it turned out that basically like many people converged on the same bugs, and I'm not sure why that happened. It may be that they were very obvious bugs or they were very similar to bugs that were found in other browsers. So what are my goals? I wanted to find a lot of bugs in Chakra. Understand and improve some of the weak areas, or at least drive improvements in those areas. And I was hoping to find deep and unusual bugs, asterisk, because that didn't end up happening. Everyone pretty much found the same set of bugs. And my approach was mostly code review. I find especially if you're in the situation of wanting to find a lot of bugs and kind of do a comprehensive bug finding, find all the similar bugs so that they can be fixed. Code review is typically the best. You find quality bugs and you kind of know their quality up front because you know what's causing them. I thought I would find bugs that, maybe live longer and are more likely to be used by attackers, although that turned out not to be the case. And also I found it easier to fix or get entire classes of bugs fixed. Something I found interesting is I was talking to one of the other people that found a similar bug and used it in Pwn to Own, and he said that, he wasn't even sure, is it a use after free? Is it a an overflow and that sort of thing. And that's kind of typical of bugs you find through fuzzing. Sometimes it's not always clear what causes them, but if you spend a lot of time looking at the code, you can figure out why they happen and hopefully find like all 10 places where that happens. So how do you start? I have my RTFS there. Reading the standard, in my opinion, is really important if you want to find good browser bugs and bugs in script engines. You would be amazed by the stuff that's in there. There's a pretty crazy stuff, and a lot of it causes bugs. If you can't bring yourself to read the standard, I'd recommend the Mozilla docs. They're fantabulous. They have every method, a description of the method, browser compatibility in a table, and then a link to the ECMAScript standard where you can find more information. You'd think you died and went to ECMAScript documentation heaven, which, by the way, is where I totally hope I go when I die. Many features are infrequently used, and this is the ones that cause bugs. I find like there's almost a trade-off. Like every so often you do find a bug in a really commonly used feature, but most of the bugs are in stuff that less than 1% of web pages, or even way less than that, ever use. And the features can be very deeply intertwined. Quite often, one thing that turns up in the standard has really deep-reaching impacts other places. And one example of this is the array.species creator. So the idea here is in JavaScript, there's lots of different array methods where it'll copy the results into a new array. For example, slice is just subarray, and it will get two indexes and then create a new array and copy your array into it. But then, the problem is, let's say the thing I'm slicing is actually a subclass of array and not actually the array. Do I return the new thing as a subclass or just like a regular array? And of course, instead of picking one, why don't we make this a configurable property? And then you can specify which one you want. And this is, of course, easily implemented by inserting a call to script into every single native array call. So that's, basically impacts everything you do with an array and makes it vulnerable. This can interact with other design features. For example, I think one of the most important things in design decisions in creating an ECMA engine is how arrays and how objects work. And most browsers do something like this. This is exactly what Chakra does, which is you start off with like a very small, not complex array, and then as you add new features to it, it becomes a more complex object. So in Chakra, you start off, you just have integers in your array, and then you're an integer array. As soon as you get a float added to you, you become a float array, and that has to be twice as long because there's 8 bytes in an array. And then if you add an object to it, it then becomes a var array, and that means instead of having numbers in the array, you have pointers to objects. And then the very final stage of an array, which doesn't happen very often, is what if you configure a property to an array? What if you make one element of the array read-only? Then you have to actually have a structure with the property of every element in it, and that's what they call an ES5 array. And how do they implement this? They actually swap out the vtable. They very literally, cast the object to bytes and then change the vtable to be something different. And I found that fairly surprising, but that's what happens. And it did have some interesting consequences with regards to bugs. So to give an idea of how this works, you have your int array, and the way arrays are structured. And this is actually a fairly elegant design. They have every array is an array object, and then it has a head that points to a segment of the array, and then the segment has where it starts and its data in it and that sort of thing. So another thing to note about this is a lot of browsers have a concept of a sparse array and a dense array, and Chakra doesn't really have that. Basically, your dense array is just a very, very small sparse array, and then if it becomes sparse, they can just add more segments. So if you change the type, let's say you added a float to this, it changes its type, it swaps out the vtable, and then it goes down this chain, and for every segment, it will allocate it so it's now twice the size, put in the things as floats, and then move on. So to give an example of how these two things combine to cause bugs, there's this bug, which is in array.filter, and there's a similar one in array.map. So to show how this works in the script engine first, you start off and you want to do this method, which basically it runs a function on every item in an array, and then if this function you provided returns true, it goes into the new array, otherwise it does not go into that array. So you start off, you have to create the array, and realize this is a constructor you provide, it can be anything, and then it does the call on every single one, and then it calls this direct set item map function, and that's kind of where the problem is. This one's actually only defined for the variable arrays and none of the other array types. So if you call it, it's type confusion. And the mistake here is that the developer assumed that when you're creating the new array, it would be an object array, because that's what by default the constructor does, but you can override it, and then that will cause type confusion. And here's what this looks like in JavaScript. Starting at the bottom, you create the array, and then you redefine in the middle the species, and that's what returns dummy, which is the constructor that actually makes your array. Another property of JavaScript I read about, this is like absolutely wild, but you can put interceptors, getters and setters on the index of an array, and this has all sorts of interesting impacts. Like, here's how it works. You have your array, and then you call object.define property, and you add a getter and a setter to this array, and then if you change it, it will call this getter and setter. And what's even kind of weird is quite often if you use like internal properties of an array, like let's say you call array.push on that, it will still trigger this accessor, and that can do all sorts of things that the developer wasn't expecting. And this gets even more interesting if you look at how objects work in JavaScript. So every object, it has its class hierarchy, and this is defined by the prototype. So you go, you start off, let's say you're trying to get a property, like property 1. You'll go and see if it's in the array object. If it's not, you get the prototype, and if it's not there, you get the prototype's prototype, and you go all the way up the chain until it's null, and that's how you get a property. So let's say you define the property of not the array, but the prototype object that is given to all arrays. Then that also works, and then you create these arrays after you've done that, and without ever touching the array, it will still trigger these accessors. Now, it's not perfect, because if you initialize the array, like in B, it doesn't work. But if you are creating an empty array and then putting stuff into it, you can actually intercept this before you've ever touched the array. And what's cool about that is if it's done in a native method in the engine, quite often it will call the setter, and you can get a handle to that array before it's even been returned to you, which can cause bugs. Here's an example of a bug caused by this, and also the array typing. So it's pretty simple. This is array.toString, which is also called array.join, and you just basically it cycles through every element in the array and then converts it to a string. So it does this, and it tries to get it, and this is actually a templated function. So it will call in, and then it will try and convert the item, which can execute script, and then that can actually do the thing where it swaps the vtable out. And at that point, it's too late, right? You're in a templated function, and it's not going to go back and change you to have the right template. So then everything you do after that is on the wrong type, and it's type confusion. And here's an example of the code that causes this. Notice that you're actually putting the getter and setter on the index. So that's the thing that triggers the code that can change the array type. Another interesting JavaScript property is the proxy. And this is basically, what if you're not satisfied with using other things to debug JavaScript. You want to debug JavaScript in JavaScript. Well, then you need to have this function called a proxy, and that can intercept everything that you do to an object. I'd encourage you to read the spec for this. It's very so full-featured. You can make it execute code if you call the constructor, if you get a property, if you get the property definition. There's just a very, very large number of things that you can intercept using this method, and it causes a number of problems, both in browsers. There are also issues in Flash due to this. Basically, because this is supported, every single operation that handles an object in JavaScript has to, consider the possibility that the call could be intercepted. And that's a hard thing to always have on your minds. There's always mistakes that are due to not realizing that an object could be a proxy. Here's one that happened in Chakra. One of the interceptors you can get on a proxy is the prototype. So when you know how I showed the proxy chain, if you have or the prototype chain. If you have a proxy, that's not true. Just at one point in the chain, you call a method, and then that returns the next prototype. And this is unfortunate because in Chakra, and actually most engines I've looked at, they perform a check when setting a prototype. It can be certain things, it can't be certain things, and even more, sometimes you want to do things to the object to make it perform better as a prototype, make it a certain type, remove certain optimizations, that sort of thing. And this doesn't happen if you have a proxy giving back the prototype. So in this case, this is a function internal fill from array, and this is, if you, for example, sort an array, you want to get all the objects out of the prototype first before you sort it, otherwise sort will become more complex. So before it calls sort, it will use this function to get all the properties out of the prototype and put them into the main array before sorting it. And this one, you can see at the bottom it gets the prototype, and it made the assumption that the prototype is of a certain type, that it is a var array, because normally when you set the prototype of an array, it makes sure that it's a var array, but in this case, that violates that assumption, and it's once again type confusion due to this direct set item at, which only works on certain array types, which is not guaranteed to be the case. And this is the code here, just to show how this works. You create the proxy with the handler, and it has the prototype intercepted at the top. Another fun feature of JavaScript is new target, and it's another kind of weird property. It's used for subclassing, but you can also just use it. I'm using reflect to create any object you want with any prototype you want, and it's not that frequently used. But what's interesting is they implemented it in Chakra so that if you have new target on a function, it's just an extra parameter. So they'll push the extra parameter on the stack and then increment it and then have a flag, which was great. But unfortunately, another call also did this for something different. So this was a really fun bug. Basically, if you create a proxy which does new target on a val, you'll get type confusion because a val can also get a extra arg for another reason. I really like this bug because you can tweet it. If you put a proxy on a val, it's a fairly bad type confusion, and this is kind of, I'd say, also a case of untested code. A lot of the other stuff I've showed you is kind of weird JavaScript. This is something you absolutely should be able to do if you're going to write your JavaScript debugger in JavaScript, and I guess just no one ever tried it. And then there's this last bug. Not every bug is due to, weird JavaScript features. Sometimes mistakes happen, and there was this one where this assert at the bottom, I think, was very much intended to be some sort of hard error, but it wasn't. So this is just a simple uninitialized variable. If you have 1, 2, or 3 args, it does the right thing. If you have more args, it just falls through and doesn't initialize it. And this was also wonderfully tweetable. Very easy bug to reproduce. So that's it. I think from doing this, I learned a lot about how the ECMAScript implementation choices lead to bugs. There's lots of things in JavaScript that are very unusual and not very well used in web pages, and can lead to a large number of bugs. So I'd say, if you're doing this on yourself, learn about these underused features, and especially the ones that add into in execution points. And I think you'll find a lot more bugs. And then I'm going to end with a bit of a call to join the party. A few people have been working on Chakra, not very many yet. So I'd encourage everyone, if you thought these bugs are cool, try your hand at it. I bet there's a lot more bugs to be found. And that's it. Thanks a lot. And if anyone has any questions, they can ask them.